Hello everyone. Today I'll be presenting about the AIS-156 Series Vibration Test, which is a crucial part of EV battery validation. This test is mandated by the Government of India and regulated through ARAI to make sure that EV battery packs are mechanically robust and safe under real-world vibration conditions. The AIS-156 Vibration Test mainly checks the structural integrity, electrical connections, and mounting reliability of the battery system. By doing so, it helps prevent failures and ensures that the vehicle maintains its performance and safety throughout its entire lifetime. In this presentation, I'll walk you through the objectives, procedures, passing criteria according to AIS-156, and the overall importance of this test in the EV industry. The purpose of this test is to verify the safety performance of the REIS under a vibration environment which the REIS will likely experience during the normal operation of the vehicle. Now let's move on to the overall procedure for conducting the AIS-156 Vibration Test. As you can see, it's divided into 5 key stages. First, pre-test preparation, where we set up the basic conditions for testing. Second, installation or setup, which covers mounting the battery on the vibration system. Third, test procedure, where the actual vibration cycle is performed. Fourth, post-test checks and passing criteria to verify the battery's safety and performance after testing. And finally, failures and solutions, where any issues are analysed and corrected. Each of these stages will be explained in detail in the upcoming slides. So, before starting the vibration test, we make sure all test conditions are set properly. As you can see here, the ambient temperature should be around 20 plus or minus 10 degrees Celsius, and the state of charge of the battery pack must be above 50%, though most OEMs prefer it close to 90%. We also ensure that all protection devices for safety and performance are active. And as noted below, a charge-discharge cycle can be done beforehand for comparison. But since AIS-156 mainly focuses on safety, it's optional. The second step is installation. As per AIS-156, testing can be done on the complete REESS or on main components like cells and connections, but it must still represent full battery safety. If the ECU or BMS is placed separately from the casing, it can be skipped from the test. The key point is, the battery must be firmly mounted on the vibration setup, as shown here, using a suitable fixture so that vibrations are directly transmitted to the tested device. Proper installation ensures accurate and realistic vibration results. Now, moving on to the test procedure, which is the actual vibration cycle defined under AIS-156. Starting with step 1, we apply a sinusoidal vibration to the battery pack. This forms the base excitation for the entire test. Then, in step 2, we follow a logarithmic sweep of frequencies. As you can see on the slide, the sweep goes from 7 Hz up to 200 Hz, and then back down from 200 Hz to 7 Hz. Each sweep takes 15 minutes, and this ensures the battery experiences vibration across the full frequency range. Now, if you look at the tables on the right side, these show the correlation between frequency and acceleration levels. Table 1 and Table 2 specify the acceleration limits that must be met at each frequency band. Manufacturers may increase maximum acceleration levels if their product requires a more severe test. Moving to step 3, the complete sweep cycle is repeated 12 times, which gives us a total test duration of 3 hours for one axis. Finally, in step 4, the test is performed in the vertical direction or according to the battery's mounting orientation as specified by the manufacturer. And at the bottom, the note highlights that companies may request higher acceleration or higher maximum frequencies, depending on their validation needs. This slide shows the practical demonstration of the vibration test. On the top left, you can see the test profile. This graph shows how the vibration frequency varies from 7 Hz up to 200 Hz and back, matching the AIS standard profile used for testing. Just below that, the program window displays the input parameters, the set frequencies, amplitudes, and sweep times that control the vibration table. And here, on the right side, you can see the actual vibration setup, where the battery is mounted firmly on the test fixture and tested on the shaker table. Together, these show how the vibration test is executed in real conditions, verifying that the pack can withstand continuous road-induced vibrations without failure. Once the vibration cycle is complete, we move to post-test checks, as shown here. The main parameters we verify are mechanical integrity, electrical performance, insulation resistance, and overall safety. The pack must show no rupture, fire, or leakage, and should continue to operate normally after the test. For high-voltage systems, insulation resistance should be at least 100 ohms per volt of working voltage, and of course, there must be no hazardous events during or after testing. If all these criteria are met, the pack officially passes the AIS-156 Vibration Test. If not, then the design or mounting structure needs improvement before retesting. Pointing to the note below, for low-voltage systems, up to around 60 volts DC, the same conditions apply, typically for 48 to 56 volt batteries. We also make sure there's no shorting or insulation failure, and the insulation resistance stays within the manufacturer's specified limits. Continuing with the post-test stage, after the vibration test is complete, we perform what's called a standard charge-discharge cycle, as described in Annex 8, Appendix 1 of the AIS-156 standard. This step helps verify that the battery pack still functions properly after being exposed to mechanical stress. In simple terms, Annex 8 explains the functional verification test. Basically, we recharge and discharge the battery under controlled conditions to confirm that it's operating safely and efficiently. This test is mandatory after any vibration or mechanical stress, unless the battery's internal safety systems prevent charging or discharging for protection. Finally, once the cycle is complete, the test ends with a 1-hour observation period at ambient temperature, just to ensure there are no delayed reactions like thermal instability, leakage, or other abnormalities. This final verification gives confidence that the battery can safely return to operation after the vibration stress. Now, as you can see here, this slide focuses on the common failure modes that can occur during or after the vibration test, and their possible solutions. For instance, if you look at the first row, connector or terminal loosening, it's mainly due to contact resistance and heat buildup, which can be resolved using locking fasteners or flexible bus bars. Similarly, other cases like bus bar cracks, cell movement, insulation drops and BMS faults are listed here with their respective corrective actions. And as mentioned below, if any failure is observed, we perform a root cause analysis, implement design improvements, and then repeat the vibration test under the same conditions to confirm the fix. Is there any custom vibration test allowed in AIS-156? So, as you can see, AIS-156 actually allows a custom vibration test option under certain conditions. You can see in the clause mentioned, if the manufacturer and test agency agree, a vehicle-specific vibration profile can be used instead of the standard AIS-156 table. On the right, the table explains the difference. The standard test uses the default AIS-156 vibration frequency and acceleration profile, which applies for general type approvals. But under the custom test, the OEM can use their own vibration data, usually taken from real road testing of that particular vehicle. For example, if you're testing a scooter battery and the OEM already has vibration data from that scooter running on Indian roads, they can propose that as their test profile. If the test agency finds it realistic, they can approve it, but that approval will only apply to that specific model, not any other brand or vehicle type. Which quarter? November Services provides comprehensive AIS-156 vibration testing and consultancy solutions for EV batteries and components. Using advanced test systems, we ensure compliance, safety and durability as per AIS-156 standards. Our expertise supports clients from testing to certification, delivering reliable results and engineering confidence. You'll find the link below for AIS-156 vibration document. Thank you for your attention. We truly appreciate the opportunity to present our vibration testing capabilities with you today. At November Services, our commitment is to deliver precise, reliable and globally compliant testing, backed by expert consultancy. If you have any inquiries, need support with test bookings, or simply want to discuss your requirements further, please feel free to reach out. Our contact details are shared here. We'll be happy to assist you anytime. Once again, thank you for your time and attention. We look forward to working together.